my purpose, and in case somebody's missed the instruction, they can get it this way. So we're off and running. Let me make this bigger. So several students have emailed me and asked me questions about last week's material. So we're going to start there. So today is the 4th. Wow. Not 9, not 8. Okay, let me do this. So 9/4. It's just the week of 9/4. Okay. And we're going to start with last week's problems. So page 53, number 20. So they give us an x, like so, and they tell us that this angle is 3x plus 8, and this one is 6x minus 22. So recapping last week, we were given 3 types of angles that we were looking at. One was complementary, 2 angles that equal 90. Supplementary angles, 2 angles that equal 180. And vertical angles, 2 angles that equal each other. So this one equals 90, equals 180, and these equal each other. So that's essentially what we were looking at. So anybody remember what the 2 angles across from each other are called? Complementary, supplementary, or vertical? Yeah, there's only 3 of you, so it's going to take a little bit more to participate this time. Okay, so complementary angles make a box, make a right angle. Supplementary angles make a straight line. So the angles across from each other, directly across, are the vertical angles. So we know that these 2 angles are equal to each other. And there's your equation. We can say that 3x plus 8 is equal to 6x minus 22. And then we solve. So subtracting 3x on both sides, 8 equals 3x minus 22. Add 22 to both sides. 30 is equal to 3x. And dividing both sides by 3, we get 10 equals x. And that was it. Okay. If at any time you have a question, please stop me along the way. Just feel free to unmute yourself and ask. Okay. Page 54, number 32. This one's slightly more challenging because they ask you to link 2 concepts together. Okay, so they still give us an x. So this time they tell us that this angle is x, and this one is 3x minus 8. And this one is 2y minus 17. Okay, so we just looked at anytime the angles are opposite each other, they're vertical angles. So we know that these 2 are equal to each other. So it's like, okay, well, we could start there and let's see what happens. If we write 3x minus 8 is equal to 2y minus 17, we're like, uh-oh, we have 2 different variables and only 1 equation, and we can't do that. So now we have to look and say, what else could I do? Now, that's not totally useless for us, but it's not going to help us the first go around. So if I cover this one up, we're like, okay, I have a straight line, but I still have 2 variables. Let's look at this one. So if I can look at those 2, I have a straight line and only 1 variable. So what are the angles called when they make a straight line?
A complementary, am I correctly, or no?
Close. Complementary makes the 90 degree.
Nah.
So it would be what?
I need to look at my notes.
Would it be a vertical?
Vertical are the ones that are right across from each other.
So supplementary.
Yep, supplementary. Good. So, and if you look up here, I wrote up like the summary recap up here too. So the complementary angles make a right angle or a box. Supplementary angles make a straight line. And the vertical angles are an X and they're across from each other. Okay, so that might help a little bit. So yeah, we have these two, which are supplementary, because two angles make a straight line equal 180. So we can use that as our first go around. So we can say x plus 3x minus 8 is equal to 180. Now we only have one variable and I can solve for x. So 4x minus 8 is equal to 180. And then I can add 8 to both sides. And I get 4x equals 188. And dividing both sides by 4, I get x equals 47. Okay, now that helps a lot because this equation up here wasn't totally useless because now I can take that x and substitute it right there. And then I can solve for y. So 3 times the value of x, which was 47. Okay, minus 8 is equal to 2y minus 17. So I have 141 minus 8 is equal to 2y minus 17. And continuing to solve. So I've got 133 equals 2y minus 17. And then to get rid of a minus 17, we have to do the opposite. So we add 17. And I go down to 150 equals 2y. This is why I spent a day to review solving equations, because of all of this. It's super important that we know how to properly solve an equation. Otherwise, you might know how to do the problem, but you can't get the answer because you can't solve the equation. Anyway, 75 equals y. Does that seem to make a little more sense?
Yes.
Okay, good. Okay. And the last one, page 41. Now, we did go over what the problem was asking for. However, not everybody got it. Not everybody understood it. I didn't ask you to write the question, but we're going to as for part of our notes so you can see what's happening. And I think I'm going to do it a little bit differently than I did with the other classes. I'm going to write the first line and then the second line. So 35y plus 7 equals 12. So when they say justify the step, justify the steps. All they're wanting to know is, was it addition, subtraction, multiplication, or division property? That was it. So looking at the first line, we can ask ourselves, what's missing to get to the second line? So y's are still there, the 7's still there, and the 12's still there. So what's missing? What's missing from the first line to the second line? Because that's going to be the answer to our question. It's going to go really slow if nobody's going to talk but me.
Sorry, this is that my parents are playing music.
Well, the y's are still there. They're a different value. Okay, the 7's still there. The 12's still there. So what's missing is the minus 20y. So tell me, how do I get rid of a minus 20y when I'm solving an equation?
Adding 20y
Yep,
on both sides.
exactly. Okay, so since I added it to both sides, that is the addition property. Addition property. That's all they wanted right there. Okay, the third line is 35y equals 5. So again, we're going to ask ourselves, what did they do to the second line to get the third line? So what's missing?
The +7, they
Good.
-5.
Good. So they needed to get rid of the +7, so they subtracted 7 on both sides. So that is the subtraction property. And then last, we have y equals 1/7. Excuse me. So going from the third line to the fourth line, we notice that what's missing is the 35. Well, the 35 is a multiplication, and the opposite of a multiplication is what?
Division.
Division. So they divided both sides by 35. They actually did two divisions in one, because when they got 5/35, then they divided by 5 and reduced to 1/7. But that's the division property. Okay. So this right here, these three, is what I was looking for, and they were looking for as an answer. That was it. So you may see one of these again, and I've done this particular problem for every single class, these three exact problems. So they should be in your notes, and if you have questions, you can refer back to them. But these three would be really good quiz questions in the future. Okay. Any questions on those?
No.
Okay. Okay, so let's pick up with the notes from Monday. I think 2 of you were there. And we're going to integrate what we did on Monday. So if you weren't there, you'll still get the understanding. This Monday, of course, is a holiday. But in general, I do need you guys attending on Mondays because there are some instruction and as well as questions and answers. Okay. So what we're going to do is we're going to draw 2 sets of parallel lines. So there's a line. Okay. And we're going to draw this one. So the black lines are parallel and the red lines are parallel. And so remember that they use these little feather marks or thick arrows to indicate that they're parallel. So we'll do that too. And we're going to label our angles going straight across as 1, 2, 3, 4, 5, 6, 7, 8. Jump down here, 9, 10, 11, 12, 13, 14, 15, 16. Okay, so we are going to kind of build on what we had last week in that I'm going to write this again. So last week we had complementary angles, which equaled 90, 2 angles, supplementary angles, which equaled 180, and vertical angles, which equal each other, always. This time, we're going to add to that list, and we have, and leave a little bit of room in between each one because we're going to add things to it, descriptions and examples. So we have corresponding angles. And here, if you were with us Monday, that's the abbreviation. Down here, we're going to have alternate interior angles. And here we have same side, S-S, same side, interior angles. And last, we have vertical angles again. Okay, so let's look at what are these. So I'm going to write out the name underneath, so corresponding angles. This one, alternate interior angles. INT is interior. S-S is same side. Interior angles. And of course, this is our vertical angles. Okay. So let's look at what we know about these. We already know that vertical angles are equal to each other. And if you're here on Monday, we talked about the relationships on these other ones. Corresponding angles are also equal to each other. Alternate interior angles are equal to each other. Wow, 3 out of 4 so far. But this one, the same side interior angle, is actually equal to 180. We're going to find that they're supplementary. So same side supplementary. So same side supplementary. All the S's. Okay. So how do we identify these? That's our first question. How do we identify these? So I would suggest, think about this as like a checker game. Because when you're playing checkers, you get to slide your checker in different positions. You can slide it up and down, you can slide it side to side. But more importantly, we go from like this square to the square diagonal from it. Those are going to be vertical. Then I can take that checker and I can jump it over my opponent over to here. That's going to be an alternate interior angle. And then I can go from 9 to 14. That'd be another vertical angle. Okay. So when we are talking about corresponding angles, I'm actually talking about, another pen. It's not here. Okay, we're talking about the same location in respect to the parallel line and the transversal. Same location, but this is going to be a slide. We're going to slide up or down or side to side. Okay, so that's going to be a slide side to side or up and down. Alternate interior angles, think of it like a jump. We're going to jump across the transversal. Okay. That's why we alternate. It's going to be a jump across the transversal. But notice the interior angles right here, that means that they're between the parallel lines or between the parallel lines. If they're between the parallel lines, you only have 2 choices. It's going to be alternate interior, same side interior. So the same side interior is just like it says, it's going to be on the same side of the transversal. Same side of the transversal. Let me make that a little bit bigger. the same side of the transversal. And then looking at the vertical angles, again, it's directly across. Okay. So all we're going to do right now for this particular one is we're going to give one single example so that when you're looking back at your notes, you can go, okay, I think I kind of understand how we're getting this. So corresponding angles, like number 1. If I look at angle 1 and I want to slide, I can slide down, and it would be, if you're looking at these 4 angles, the 1, 2, 5, and 6, it's in the top left-hand corner. If I want to slide down, I still want the one that's in the top left-hand corner. So would it be angle 9 or angle 10? I want the angle that's in the top left-hand corner down here of these 4. Is it going to be angle 9 or angle 10?
9.
9.
9. Good. 9. So an example would be angle 1 and angle 9. So we're going to write that over here. So angle 1 and angle 9. That's an example. You could have also had angle 1 and angle 3. So if we slid to the right, we would have had angle 1 and angle 3. Those would also be corresponding. There's all sorts of corresponding. There's angle 6 and angle 14, angle 8 and angle 16, angle 3 and angle 11. Okay, so they just have to end up in the same spot. Okay. Alternate interior angles. So let's look at angle 8. So if we look at angle 8, we need it to be interior. So in between the 2 parallel lines. So what I'm going to do is I'm going to use my papers and block this off. Okay. So we're going to cover up one of the transversals. And then I'm going to look at just between the 2 parallel lines. So this is a jump across the transversal, the red line. So if I jump across, am I going to land at angle 11 or angle 12?
Um, 11.
11. Good. Because I jumped across the red line to angle 11. So this is angle 8 and angle 11. Another example would be angle 7 and angle 12. Those would be alternate interior because I jumped across. Okay. Another example would be angle 14 and angle 11, or angle 15 and angle 10. Okay, so they're definitely alternate interior angles. We jump. So same side interior. So I'm going to cover up one of my transversals. And let's do this one. Same side interior. And I'm going to look between the two parallel lines here. And I'm going to look at angle 10. So if I'm on the same side of the transversal, this time it's the black line, am I going to end up at angle 11 or 15?
Um,
Which one?
I'm thinking 11.
11. Yep. Because it's on the same side. So I can't jump over. That means it has to be angle 11. Okay. So that would be an example of that would be angle 10 and angle 11. That's my same side. So looking at other examples, so angle 11 and 7, 7 and 6, even 2 and 3. 2 and 3 would be same side interior. 9 and 5 would be same side interior. Okay. Okay, they can be on the left side of the transversal or they can be on the right side, but they have to be on the same side. Vertical angles, let's look at angle 4. The one directly across from angle 4, would that be angle 7 or angle 8?
Cross from which one? Sorry, I'm writing on the
Okay, the one directly across from angle 7, would that be, I mean, sorry, directly across from angle 4, would that be angle 7 or angle 8?
8.
7.
Okay, well, directly across would be 7. The one next to it would be 8 or 3. Okay,
Wow.
so across is like in your X, it's across this way. Okay, so this would be angles 4 and angle 7, directly across. So like 3 and 8 would be directly across. 12 and 15, 11 and 16, okay. 2 and 5, 1 and 6. Those are vertical angles. Okay, so this is a really good exercise in starting to understand how they relate. Now we're going to do one where we're going to do another. We're actually going to look at different angles here. So we're going to do 8 of them for practice. So number 1, go ahead and write these down, and then we're going to identify them. So angle 7 and 11. And I'll give you a minute to write these down. Number 2, angles 14 and angle 16. And number 3 is angle 4 and angle 10. Number 4 is angle 3 and angle 6. Number 5 is angle 6 and angle 11. Number 6 is angle 2 and angle 10. Number 7 is angle 2 and angle 3. And last, number 8, angle 7 and angle 12. So we're going to practice using the same picture above, labeling these. So we have the 4 options, but there's actually a 5th, which is none of the above. And I'll explain how we get a none of the above. When I look at my angles, and I should be able to cover one transversal and see both of those angles, like either that one or this one, etc. If there any time I cover one transversal and I can't see both angles, then it's a none. They'll still have a relationship like equal or supplementary, but they won't be directly one of these. Okay, so angles 7 and 11. So I can cover this transversal and I see angle 7. I can cover this transversal and see both 7 and 11. Okay. So the first question I would ask myself if I'm starting to learn how to do this in practice is, are those 2 angles in between the parallel lines? Would that be a yes or a no?
Yes.
Yes, they are. They're in between the parallel lines. Okay, so my next question would be, do they jump over the transversal or are they on the same side?
They jump.
Okay, so if I'm at 7 and I want to go to 11, I'm not going to jump over. Jumping would be at 12. So these are actually on the same side of the transversal. You can cover these up over here, and you'd see that they're both on the left side. Does that make more sense?
Yeah.
Okay, so these would be the same side interior angles. So S dash S interior angles. Same side interior angles. Okay. So 14 and 16 So 14 and 16, I can cover that one up. So question, are they both in between the parallel lines? So these are my parallel lines. Are they both in between the parallel lines, 14 and 16? We don't see a 16 there, right? Okay, so we'd say no, they're not in between the parallel lines. Okay, so if they're not in between the parallel lines, we can automatically eliminate the alternate interior and the same side interior because they're not inside. That whole INT, interior means inside, they're not. So they're either going to be corresponding angles or they're going to be vertical angles. So looking at 14, is 16 right across from 14? The one right across from 14 would be 9. Okay, so 9 would be my vertical angle. But if I look at 14 and I think about sliding it to the right, these are both in the bottom right-hand corner of my transversal and parallel line. Okay, does that make sense?
Yeah.
Okay, so these would be corresponding angles. Sometimes you have to do a process of elimination when you're first starting so you can learn how to visualize these. Number 3. Okay, so angle 4, there's angle 4, but I don't see angle 10. Okay, there's still angle 4, but I still don't see angle 10. There's angle 10, but no angle 4. And the same here, there's angle 10 and no angle 4. So that's where we get the none of these, or none. I'd highly recommend you cut a little piece of paper or a couple of them, maybe different color. So you can cover these up and ask the same questions. Okay, angles 3 and 6. Okay. So if I cover this transversal up, I see both angle 3 and angle 6. And I notice that they are between the two parallel lines. So I know we're going to have an interior angle. If I'm going from angle 3 to angle 6, does it jump over the transversal or is it on the same side? From 3 to 6, does it jump over the black line or is it on the same side?
It jumps over.
It does jump over, okay? So it goes from 3 to 6, it jumps over the black line. So the jump is an alternate interior. And I appreciate your participations, I really do. There's actually 3 of you and the others are really quiet right now. So alternate interior angles. Okay. Good. The more involved you are with the participation, the more comfortable you're going to feel with the content. It's kind of like practicing a sport. You can't just watch and think like you know how to do it. You have to get out there and practice it. Okay, so 6 and 11. To get 6 and 11. I can cover up 6. I mean, this transversal, I see 6, but not 11. This one, I see 6, but not 11. I think you're going to know where I'm going with this. Okay, this one, I see 11, but not 6. And this one, I see 11, but not 6. Okay, so that's where we're going to get none. It's none of the above. So angles 2 and 10. Okay, so if I cover up this transversal, I can see both angles 2 and 10. So think about it for a minute. And somebody tell me, what do you think? First, ask yourself, is it an interior angle? If not, is it a slide or directly across? Two and 10, angles 2 and angle 10. Look at your options. Okay. Josh and Faith, you guys are awfully quiet.
It would be same side interior, or no?
Okay, you're close. They are on the same side, so that's a really good step in recognizing. Okay, but ask yourself, is it because you selected the interior angle, same side interior? We have to ask ourselves, are they both inside the parallel lines? Okay, angle 10 is, but angle 2 is not. Okay, so we have to say no to the interior angles. So would this be a slide down into the same location, or would it be directly across? So would it be corresponding or vertical?
Corresponding.
Corresponding, nice. So these would be the corresponding angles. Okay. And they do get a little bit easier. Angles 2 and 3. So there's my 2 and there's my 3. I happen to notice that they are between the same, the parallel lines. So this time, are they going to be same side interior or alternate interior?
Alternate.
Alternate. Nope. Sorry. Okay, look. On here they are. They're on the same side right there. Okay, that's going to tell us that they're the same side interior. In order to be alternate interior, they would need to jump over that black line. Okay, like a checker piece jumping over the opponent. Okay, does that make a little more sense?
Mm-hmm.
So when you've narrowed it down to the interior angles, it's either going to be on the same side, like 2 and 3, or 6 and 7. Oops, sorry, can't see that. Or 6 and 7. Or it's going to jump over like 2 and 7. Okay, or 6 and 3. But this time, they happen to be on the same side. So these are the same side interior angles. Okay. Last one, angle 7 and 12. I'm going to cover up that transversal. And I'm looking at angle 7 and 12. So think about it for a minute, and somebody tell me what you think. So are they interior angles or not?
I think they're interior or
Very
alternate.
good. Yep, alternate interior. Because they're between the two parallel lines and they jump over the transversal. Nice. So alternate interior angles. Okay. I know that was a little painful because we're practicing. We're still kind of unsure right now, but it does get a little bit easier as you practice. Okay. So right now we're going to draw another set of two parallel lines. And we're going to do something a little bit different. My parallel lines don't always have to go the same direction. I mean, like they did up there. That one's slanted to the right. These are slanting to the left. Okay. So those indicate that they're parallel. So I'm going to make a really bold statement here. I'm going to say that I can give you one angle, let's say the value of 100. And you can literally find all the other 15 angles. And you're like, that's a pretty bold statement, but let's do it together, okay? So looking at this angle next to it, so what would the value of the angle next to it be? What type of line does that make?
Like what type of angle it makes?
Yeah, the 100 and the one next to it. What type of angle or line does it make?
I don't know.
Okay, well, it's not a perpendicular line. It makes a straight line, makes a straight angle. Okay, so these two angles together are going to equal what? Two angles that make a straight line have to add up to be what?
180.
180. Yep. So if this one's 100, what's the other angle going to be?
80?
Yep, 80. Awesome. I just found my blue pen. Okay. So this one is 80. Yeah, okay. It is 80, but I don't want it in blue. I want it in red. Okay. I have a reason for it. Okay, so what is the angle directly across from the 80? Or the vertical angle? What do we know about vertical angles or what?
They're equal.
They're equal. Nice. So if this is 80, the one directly across from it is also 80. Notice that that 100 there and this 80 is also supplementary. They make 180. So what's the value of the angle next to that one?
100?
100. Yep. Nice. So there were only 4 options there. We didn't have a lot. Because the 80 and 100 are supplementary and this 100 and that 80 are supplementary and so on. That's why we know that vertical angles are equal. That's how I can demonstrate to you that vertical angles will always be equal. Okay, so now let's look at, if I take this 80-degree angle here and I jump over to land right here, that would be an alternate interior angle. And what do I know about alternate interior angles? They're what?
You're across.
They are across. Are they going to be equal or supplementary?
Supplementary.
Not if they're across.
Oh.
Okay, across it will always be equal. Okay. Now on the same side, check out what happens here. So if they're on the same side, those two, that 100 and that 80 is going to be the supplementary angles. Okay, that's why on the same side, they are supplementary. So what is the value of this angle next to the 80 going to be?
$100?
Yep, It's going to be 100. I could have said that these two are supplementary, or I can say that this 100 right here with an alternate interior gives me 100, or there's another option. See this 100 up here? I could slide it down to be a corresponding angle, and it's still 100. So you can start to see that there's like 3 or 4 different ways to get some of these answers. And then the angles directly across. So this one would be 100, and this one would be 80. Okay, and I could have used my corresponding angles to find that. This one would be 80, this one would be 100. Okay, so now let's go to the other side. If I take this 100 over here and I slide it over here on the bottom left-hand corner, what's that value going to be?
100 as well.
100 as well. Awesome. Okay, and then check it out. If I had used this 100 and did an alternate interior angle and jumped over here, it still would have been 100. Okay, and then I can actually like vertical angle it here. I can either say these are supplementary, or I can say this is a corresponding angle, and I can slide it over here to the right, and that would be 80. And then I can do a vertical angle with this and have it 80, or I could do another alternate interior angle and jump it over. Okay. Now moving to the last corner, I can say if this is an inside angle, the one on the same side interior angle is going to be what? Equal or supplementary? Same side interior angle. Are they going to be equal or supplementary?
Equal.
Okay. Same side. Okay. Here the S's there. Same side. Think SS and S. Same side is going to be supplementary. Okay. So this one over here would be the 100. Same side interior angles. That's probably the most difficult for students to visualize sometimes, but we'll get it. And I could have done, with this 100, I could have jumped over and had an alternate interior angle and they would have been equal. From this 100, I could have went a corresponding angle and still got 100. So here, or I could have used this first 100 and went backwards and had an alternate interior angle. So we know that this one's going to be 100, and the angle next to the 100 is going to be what?
80.
What's it going to be?
80.
80.
For them.
Yep. Those are also going to be 80 because they're supplementary right next to each other. So my bold statement was true. I gave you one angle and we filled in the other 15. That's pretty amazing. But the reason I did this color coded is because I wanted you to see all the different angles that are equal to each other. So when I had one of those, none of these, I think it was like angle 4 and angle 10. Angle 4 was over here and angle 10 was over here. And what you actually notice is they are still equal, but not in a direct relationship, but from a chain of events, like alternate interior angle, vertical, and then corresponding. Okay, but we can tell that they're equal. Something else to notice, if I cover these up, let me do this. Oh, there it is. Okay. So look at this parallelogram in the middle. Parallelogram when two opposite sides are parallel. What do you notice about the opposite angles in the corners? if this one up here is 80, and this one directly across from the parallel, in the parallelogram is 80, this one's 100 and that's 100, then we can say they're what?
They're trying to think. I can't really.
Okay, well, 80 and 80, we're going to call them equal. 100 and 100, we call them equal. We actually have a theorem that we'll be coming up to that says the opposite angles of a parallelogram are equal. This is why. Okay. I just thought it's kind of a neat concept to see, but when you see it with real numbers, it's a little bit easier. I can also say that the consecutive angles, the ones right after the other, like this 100 and that 80, that's consecutive. This 80 and that's 100, that's consecutive. Consecutive angles are supplementary because the consecutive angles are the same as same side interior angles. Now I'm kind of throwing in a lot of extra stuff that just so that when we get to it again, you're going to go, oh yeah, I remember Mrs. Richardson saying that. Okay, but this is why. Okay. Another thing that you're going to need to know for your assignments, the 3 angles of a triangle. Anybody remember what the inside angles of a triangle have to add up to be? You may not, but you may have covered it like in pre-algebra or math 7. Okay. So the 3 angles, what is it?
180?
Yep, good. 3 angles of a triangle have to equal 180. So we know that A plus B plus C is equal to 180. Okay. And the last of the content that we're covering, because I'm going to go over 2 example problems, or from your assignment, is a short review of an algebra topic. And we do algebra reviews when you might be using them in your assignment. So that's why we do it. So let's look at this. This is a review of systems of equations. And the whole reason we do this is when we have 2 variables and 2 equations, 2 variables or unknowns. So if I give you the equations, 5x minus y equals 20, and 3x plus y equals 12. Right. So if you think back to when you saw these before, because these are linear equations. We know it's a linear equation because it has an x and a y in it. That's the requirement. If we were to, there's 3 ways to find the solution. We could graph it, okay? And the whole purpose of graphing it was to find where did they cross? Where was that one point that they had in common to make them both true? Okay, so unless they were parallel, they have a point in common. But graphing, it's kind of, sometimes too much work. So we could use substitution. Substitution we'd use when we had either an x equals something or a y equals something, and that was pretty easy. But when we have them all on the same side like this, an x and a y equals a number, then we would tend to use elimination. We would use elimination, where we would get rid of either the x's or the y's. And there's a requirement for that. Actually, there's 2 requirements, but just counting. Requirement number 1 is that they have opposite signs, like a plus and a minus. Requirement number 2 same coefficient. And remember, a coefficient is the number in front. So if I wanted to eliminate my x's, we're like, they don't have the same sign, and they certainly don't have the same coefficient. Sorry, that was my alarm. So we'd probably go, okay, let's maybe hold off on the x's and see if we could eliminate the y's. So looking at the y's, we have, they're both opposite signs. One's a plus and one's a minus. And if you'll remember, if there's no number in front, it's automatically a 1. So they do have the same coefficient and opposite signs, which makes us really happy because then we don't have to do any other work. So we're going to simply add down. So add down. And it eliminates one of your variables. So 5x and 3x is going to make 8x. Your y's would cancel, and that equals 32. And then solving for x, we divide both sides by 8, and we get x equals 4. So there's half my answers. Questions on that part? Now, sometimes it got kind of tricky when you'd have to, make the x's line up, but I'm not doing that to you. I just want, kind of a basic, do you understand how to do it? Because these problems do come up once in a while. Okay, so now that I have x equals 4, I can plug it back into one of the equations. Either equation is fine. You will get the same answer. However, I will generally use, and tell my students it's easier, to use one that has a positive coefficient, because some students forget to bring the negative along or forget to divide by the negative, and then they get a wrong answer. So if you have an option of doing a positive value, I would suggest that. Okay. So let's do this one. So 3 times the value of x, which was 4, plus y is equal to 12. And then solving, 12 plus y equals 12. Well, our equation solving skills says I want to get the y by itself, so I'm going to subtract this 12 on the left, and we get y equals 0. 0 is a number, so we have x equals 4 and y equals 0. In algebra, because this is a coordinate of a solution, we would have written it as 4, 0. In geometry, we're not so much using the elimination method to find a coordinate as just the answers for x and y. So you wouldn't use a coordinate, you just have x equals and y equals. And we're going to possibly use this on page 82, numbers 18 and 19. Okay, that would be a good candidate for it. You have to figure out the relationship to the angles first, and then go from there. Any questions on that? Okay, let's do 2 problems from your assignment for the week to get you going. And then I'm going to give you a couple options of what you can do after that. Okay, so I'm going to go ahead and turn my page. Anybody still writing? Okay. Now, this is going to be important. You can unmute yourself and participate because these are a little more challenging, and I really want to give you resources and tools as to how to solve these. Okay, so page 81, number 8. So we're going to draw the pictures on these. You know what? I'm going to use a different page because I don't want it to bleed through. So page 81, number 8. We're going to draw the picture. It's actually a trapezoid. Trapezoid has one set of parallel lines. Okay, so I'll give you a second to copy down the problem. Some of you may realize that doesn't really look like what we were just doing. I don't see like my parallel lines and my transversals. Well, that's because it's not in the same form. So what I would recommend, extend your parallel lines. Extend them so that it looks more like what we were just doing. Okay. Extend your transversals, the line going through your parallel lines. And your transversals don't always have to be parallel to each other, because this is like two problems in one. Now it looks more like what we were just doing. Okay, so if you, let's look at this one. I need to identify the relationship between those two angles that both have an X. So look at your options, corresponding, alternate interior, alternate, or same side interior, and vertical. And what would they be? Any guesses? Okay, until you can identify the relationship of the angles, you won't be able to solve the problem. Go through the checklist of your questions. Are they between the two parallel lines? If so, are they on the same side of the transversal? Are they on the opposite side? What do you think?
They're on the same side.
They are on the same side, and they're on the inside, which makes them same side interior angles. Okay. Awesome. Okay, so now that we've identified that, we know that same side interior angles are supplementary. So we know that these two together are going to add to give 180. So we couldn't even start the equation until we identified the type of angle. Now, honestly, you do have a 75% chance of getting it right because 3 out of your 4 are equal, but not these. Okay, so 18x is equal to 180. And dividing both sides by 18, x equals 10. Some of these, I do want you to write the picture, but not all of them are going to require work to be shown. Now this obviously, because there's an equation, requires a little bit of work. Okay, let's look at the other side. Okay. So look at that for a minute and tell me what kind of angle relationship we're looking at. What's the value of the box?
90 degrees.
It is 90. Okay, so either way. So what are the, what relationship are those two angles? Are they between your two parallel lines? If so, are they opposite sides or same side?
Same side?
They are on the same side. So again, either same side interior angles. So there, that allows us to write the equation. We know that 2y plus the 90, because it was a box, is going to equal 180 because same side are supplementary. Now, just a little side note, check this out. When I subtract 90 on both sides, I get 2y equals 90. What that means to us, and this is actually a theorem, is that this side is also a box. It also is 90 degrees. If one angle between your parallel lines is 90, the other angle has to be 90 in order for them to be supplementary. So sometimes that will lessen the amount of work that you need to do if you can recognize that, okay? But finishing the problem, we divide both sides by 2, we get y equals 45. And you're done. Okay, questions on that as to how or why I did it?
Nope.
Okay, let's look at number 9. Same page. This one looks a little more challenging, and in some ways it is, but because there's two sets of parallel lines and they just do not look, they're kind of challenging to draw. So we've got one parallel line here, one line coming up this way, and then one that's parallel to that and comes down and across, and those are parallel. Okay, so a little more challenging to draw, that's for sure. Okay, so they give us in the problem itself looks like this. That, and then this angle is 3y plus 6. And we're supposed to solve for x and y. So I'll give you a minute to finish copying it. So remember that the first place to start, first good place to start, not the only place, but is to ask, is it between the parallel lines? So let's do that. I don't want to look at the x and the y together because I can't solve those. So let's look at the x and the 120. Is either the x or the 120 between the parallel lines?
No.
No. Okay. So we just excluded the alternate interior and alternate and same side interior. So they're obviously not right across from each other, like, because right across from each other right here would be 120 down here. So let's look at corresponding. If I were to slide this angle over here, would that be corresponding? Is it on the top of my parallel line and on the left? If you're not sure, okay, it is a corresponding angle. I can actually like pick up this whole line right here and I can put it over here, and that 120 would sit right there. It's a little more difficult to see, but is it okay? Is it okay now? What we're doing is looking for ways that we can attach a value to either X or Y. Once I move this over next to the X, then I can say, oh, check it out. I actually have a straight line. What do I know the value of a straight line to be? If 120 and X make a straight line, what do I know that they have to add up to be?
Uh,
180.
Nice.
yeah.
Yep, 180. And I love the coral responses because then I get to know that more than one person knows it. Okay, so I know that these together have to equal 180. So 120 plus X is equal to 180. Or we could just subtract and say that X equals 60. Okay, so now X equals 60. Let's see if that's going to help us find Y. Okay. So does this angle of 60 and this angle of 3y plus 6, do they have a relationship that we can name? So first question, is this angle and this angle in between the two parallel lines? Yes or no? So there's my two parallel lines. Are they in between the two parallel lines? Both of them? Do I see the second angle over here in between my parallel lines?
Yes.
Okay, well, the way it's covered up, I can only see one of my two angles. So it's not directly in between, so I can't call them an interior angle. So if I'm not going to use an interior angle, am I going to use corresponding or vertical? Okay, so think
Corresponding.
about it this way. The angle vertical to this one would be here. Okay, that's not here. So what is this angle of 60 and this one together called? What relationship? There's only one other one left.
The 3y plus 6. Wait, I just came back. Sorry. My
That's
cat was
okay.
biting me.
That's all right. Okay, so the angle of 3y plus 6 and this angle of 60 have a relationship. They're either an interior angle, same side, alternate, or they're corresponding or vertical. So what would they be?
Corresponding.
They're corresponding. Thank you. Because I can slide this angle straight down and set it on top of this one. Okay, and I know that my corresponding angles are equal. So I'm going to say 3y plus 6 equals 60. Now, guys, that's not the only way to do this. Honestly, I could have said, well, I know that that's 60 because that's a vertical angle. But I'm going to, okay, these are corresponding. Use a different pen. Those right there are corresponding. But I could have said this is a vertical angle. And then I could have said that these are alternate interior angles. So see how I can get the same answer using a different relationship. Okay, so if you can justify it, do it. But if I ask you specifically, what is the relationship to these, you need to know that it's corresponding. But in order to solve, however you can get there is fine. These are vertical, those are alternate interior. These are corresponding, you're there. So we would say 3y plus 6 is equal to 60. Okay, we would subtract 6 on both sides. So 3y equals 54, and y would equal 18. Questions on that one?
No.
Okay. We're going to look at other ones really quick. Because I've had a few people email me and come to office hours looking at these. So these are the problems, and yes, you do have the answers in your book. Okay, you do not have to do 13, but you do have to do 14, 15, and 16. So number 10, think about 70 and a corresponding angle. So we can slide the 70 over here. That's how they get x equals 70. They give you this 50 for a reason. But the only real thing we can do with it is we can use it as a vertical angle. So we could put it up here. That little empty hole is 50. So now we have a 70 and a 50. But yet I have a straight line, so I know that they're equal to 180. Okay, so you can solve for y that way. Okay. Look at number 11. So if we look at, let's see, I'm going to cover that one. My parallel lines, and I've got 3x and I've got 42. What's the relationship between those two lines? They're in between my parallel lines. Are they opposite side of transversal or the same side?
Opposite side?
So we call them alternate interior angles. And we know that alternate interior angles are what? Equal or supplementary?
Supplementary?
You know, same side. are supplementary. So alternate interior angles are equal. Okay. There's only one that's supplementary, and that's the same side. Okay. So we know that this angle of 3x is going to equal the angle of 42. So we would set that equal and solve. Okay. Over here, remember what we were talking about? The three angles of a triangle have to equal 180. So you could use that here. Okay. There's other ways that you could do it. If you know that this is a right angle, then this one has to be a right angle. Together, they'd have to be a right angle. So this is 42 plus 6y minus 6, and you can say equals 90. Okay, so that's one way of doing it.
It's already time for next period.
Yes, it is. Thank you very much for reminding me. Okay, so we're just going over. So thank you very much, guys, and I appreciate your time and your participation. And have a good weekend. Oh, don't forget the quiz is open for week 2. Okay. Have a good weekend.
Thank you.
You're welcome.